should be clear. Then let's talk about one last type of class in Kotlin that is very worth talking about before we get to one more and actually the last topic for this course. And this type of class that we need to cover are so-called objects, or in other words, singletons. A singleton in software development is in the end just an instance of a class where there is only a single instance across the entire runtime of the program. So here in our case, this rectangle would technically be a singleton, since we only have one single rectangle, but it's not really a singleton because nothing keeps us back from creating multiple instances of that and passing these around. But sometimes there's real value of actually having just a single instance of a specific class in our code. And that's when we should create an object. So an object is really just the same as a class, just with the difference that it does not have a constructor. Because a constructor only makes sense if there is a unique combination of arguments that would make one single instance of that class unique. But if there can only be one single instance of that class, which is the case with objects in Kotlin, then there is no point in having a constructor, right? So for example, something we could do, which also wouldn't make too much practical sense in this case, but just that you get the idea, we could create an object that serves as a fixed size square or so. And this would then also implement our shape interface, because a fixed size square is also a shape. And then we can hit Command I to override these two fields here that we need in order to conform to this shape interface. And we can say, okay, the area is, for example, I don't know, 16. Let's say we have a side length of 4 and 4, and that actually must be float. And then the circumference must also be 16. So this way, by making this an object, we don't have a constructor. We can pass in a width value, which would be the only value needed for a square. But we say, hey, this specific instance of a square always has a fixed size. And then we can also reference this in our code. So we could say print line, and we reference our fixed size square. And we don't need to pass anything else because just referencing fixed size square already refers to the only single instance that we have in code, which is exactly this one that we define here with these fixed dimensions. But we could still also reference its area. And we could perfectly pass this fixed size square in the list to our print shapes function. You can see the when expression actually now wants us to check for that as well. And then we can say that's a fixed size square. So that's definitely something we can do. If there are data classes, there are also data objects. Although the advantage of data objects over normal objects isn't that big anymore because we can't copy them since there is no way to actually create another instance of a data object. But this still comes with a bit nicer print line statement and has some more advanced benefits that would be too much to go into here. But under certain unlucky situations, it could happen that there are actually two instances of a normal object. And if they are then compared, then they would be compared based on reference, just like the normal classes. But with data classes, then this wouldn't happen. But that's something that can happen very rarely under certain circumstances. If you want to look into this, check reflection. But that's really beyond the bounds of this simple crash course. And I know, maybe this example is not the best one since there is no real use case for such a fixed size square. We could simply create a rectangle and give it the same dimensions, so same width as same height. So same width and height. So I don't think there would be any type of shape where it would make sense to make that an object rather than a class, since in order to have a valid dynamic area, we would need to have some sort of other metric. So be it a radius, be it some kind of width or height. But in a lot of cases, it actually does make sense to have data objects, specifically if you need to inherit from a class or implement an interface like we do here, and the class that implements it simply does not need a constructor and also does not have any internal state that makes an instance of this class unique. In that case, you can make it an object since you only need a single instance in order to make sense. Very often, such objects are also used to just bundle related functionality, so just as a container for functions. So we could do something like date util, and in here we could then of course write functions like format date. We pass in some kind of date, so that would be a representation of a date in Kotlin, for example this one here, and it then returns a formatted date string based on a specific pattern, for example. It's just commonly done to group such related utility functionality in an object so that we can directly reference the object and have all the related functionality included in our autocompletion. So we could then type dateutil.formatDate. So we don't need to remember the exact name of this function here, but rather just know, okay, in dateutil, all of my date-related utility functionality is contained. So I just need to write date util, and then I can easily find all those functions that you maybe don't want to remember. So that's another use case of objects or singletons in Kotlin. One last thing about classes before we get to